Hello friends, in this short video lecture we are going to see why do we fall exactly at the same spot after a vertical jump despite the fact that Earth is rotating. To understand this, let's look deeply into the problem. Consider the Earth whose surface is shown in the figure. Let us assume the Earth is rotating in the clockwise direction with an angular velocity of 7.3 times 10 to the power minus 5 radians per second. Now, let there be a man at the point P who makes a vertical jump of height approximately zero point 0.5 meter. If the height of jump is zero point 0.5 meter, then the time of flight is approximately zero point 0.6 seconds using the formula time of flight equals 2 times root of 2h by g. Time of flight implies the time taken by this man to move up and come back to the surface of Earth. This is the duration for which this man is not in contact with Earth's surface. During this time, the point P where he stood initially would have moved this much distance. This distance is given by the formula radius of Earth times omega times time of flight. And corresponding to a jump of zero point 0.5 meter height, this distance is approximately 280 meter, which means that if you make a vertical jump of zero point 0.5 meter height, you are expected to land at a distance of 280 meters away. But in real life, this is not what we see. We know this is wrong. So let's again look into the problem. As we have said earlier, let the Earth rotate in the clockwise direction. Then the surface of Earth has a linear velocity of r times omega. In fact, not only the surface of Earth but everything, including this man, those are present on the surface of Earth, has the same linear velocity of r times omega. Now, consider a ball which is at rest. Let us hit this ball with a stick towards north. Definitely, then the ball moves towards north. That's obvious. Direction of ball's motion is always same as direction of force. Now, consider another ball which is not at rest but moving towards east with a velocity of v meters per second. And now I am hitting this ball with a stick towards north. See, the ball did not move towards north despite the direction of force being towards north. So in this case, the direction of ball's motion is not same as the direction of force. Why did this happen? This happened because the ball initially had a velocity towards east. It is this v meters per second. Due to the application of force by the stick, it attained, which means the ball attained an additional velocity towards north. The important point to note here is that this force has no effect on this velocity v meters per second which is towards east. Why? We know according to Newton's law, if there is no force in a particular direction, then there is no change in velocity in that direction. Here, there is no force along the eastern direction, so the velocity in that direction is unaffected. So after the hit, the final velocity of the ball will be the vector sum of these two velocities, which is this. This gives the direction of motion of the ball after the hit. Coming back to our problem. So as we have said earlier, this man has a horizontal velocity r omega. And when he tries to make a jump, what he has to do to make a jump? He applies a downward force on the earth and the earth provides a vertically upward reaction force due to which he attains an additional vertical velocity. As we explained earlier, this force has no effect on this horizontal velocity r omega, which means the man continues to possess this horizontal velocity r omega even after his contact with the Earth's surface is broken. So the velocity with which the man is projected from Earth's surface is not purely vertical, but it is the vector sum of these two velocities. So the trajectory of this man during a vertical jump is not exactly straight up and down lines, but it is this. So it is a projectile motion at some angle. So, what happens when you make a vertical jump is not this, but what happens is this. So, the man also moves the same horizontal distance as the point P on the surface moves. So, you land exactly on the same spot from where you jumped. Thanks for watching.